Write and balance the chemical equation, identifying the states of matter. The combustion of butane is represented by the balanced equation. 2C4H10 plus 13O2 gives 8CO2 plus 10H2O. It is crucial to note that every reactant and product in this reaction is a gas. Check for a limiting reactant or stoichiometric mixture. The container is loaded with exactly 0.01 moles of C4H10 and 0.065 moles of O2. The stoichiometric ratio of O2 to C4H10 required by the balanced equation is 13/2 is equal to 6.5. The ratio of reactants supplied in the experiment is 0.065 moles over 0.01 moles equals 6.5. Because the supplied ratio perfectly matches the stoichiometric ratio, this is a stoichiometric mixture where both reactants are completely consumed without leaving any excess reactant behind. Calculate the total moles of gas before and after the reaction. Initial moles. N initial equals 0.01 moles of C4H10 plus 0.065 moles of O2 is equal to 0.075 moles of reactant gas final moles. N final using stoichiometric conversions from the balanced equation. Moles of CO2 is equal to 0.01 moles C4H10 times 8 moles CO2 over 2 moles C4H10 is equal to 0.040 moles of H2O equals 0.01 moles C4H10 times 10 moles H2O over 2 moles C4H10 is equal to 0.050 moles. N final equals 0.040 moles of CO2 plus 0.050 moles of H2O equals 0.090 moles of product gas. Alternatively, we can simply observe that the balanced coefficients show that 15 moles of gas consumed, 2 plus 13, are replaced by 18 moles of gas produced, 8 plus 10. Thus, the reaction results in a net increase in the total number of gas molecules inside the cylinder, N final greater than N initial. Relate the change in moles of gas to the cylinder volume. Ideal gas law. The gas constant, R, is constant, and the cylinder is returned to its original temperature, 20 degrees Celsius, and pressure, 1.0 atmospheres. According to the ideal gas law, PV equals nRT. Volume is directly proportional to the number of moles of gas. V is proportional to N, when pressure and temperature are held constant. Because N increased from 0.075 moles to 0.090 moles, the volume of the gas mixture must expand to maintain constant pressure. Determine the final position of the movable piston. To accommodate the larger volume of gas at 1.0 atmospheres, the gas must push the movable piston upward. Consequently, the piston will be higher than its original position because there are more moles of gas in the cylinder after the reaction, which is represented by option A. The correct answer is option A. The piston will be higher than its original position because there are more moles of gas in the cylinder after the reaction.